Good morning children, welcome back. In the previous video we have seen about the properties or the characteristics of sound waves. Okay, we have seen about the frequency, we have seen about the wavelength, we have seen the pitch, the loudness, and then we have gone through the speed of the sound. Okay, and in this video we are going to see about the reflections, various types of reflections of the sound. So like light, sound gets reflected at the surface of a solid liquid that follows the laws of reflection. So what is the laws of reflection now? First law, the angle of incidence is equal to the angle of reflection. See the picture over here. See, this is picture given over here. There's a clock, there's a watch ticking over here. Okay, so what, this is the ray of incidence. Okay, this is the ray of reflection, and this is your normal. Okay, you have you know these terms because this is gone through in the 8th standard. Okay, the normal, the reflected ray, the incident ray, the reflected ray, and the normal. Okay, and where there is an incident ray, so this is your angle of incidence, and this is your angle of reflection. So according to the first law of reflection, the angle of incidence is equal to the angle of reflection. And second is the incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. Okay, this is your point of incidence. So all lie in the same plane. So to prove this, we have done the activity, that is, take two pipes of same length and arrange them on a table near the wall or a metal plate. Keep a clock near the open end of one pipe and try to hear the sound of clock through the other pipe by adjusting the position of the pipe. Now measure the angles of incidence and reflection. Then lift the second pipe and try to hear the sound. Means what they're telling, now change the angle of reflection and now try to listen. It will be seen that angle of incidence is equal to the angle of reflection. When you move the pipe from apart from the angle of reflection, if the angle of incidence is 40 degree and you keep the angle of reflection at 50 degree, we will not be able to hear the sound clearly. Okay, this proves that the incident ray, the reflected ray, and the normal all lie in the same plane, and the angle of incidence and the angle of reflection must be equal. Next part is that of echo. Okay, if we shout or clap near a reflecting surfaces like tall building or mountain, we hear the same sound again. This sound which we hear is called echo. It is caused due to reflection of sound. To hear an echo clearly, the time interval between the original sound and the echo must be at least 0.1 second. Means to hear the echo, the time between the original sound and the echo must be 0.1 second. Since the speed of sound in the air is 344 meter per second, the distance traveled by the sound in 0.1 second is equal to 34.4 meter. Okay, so to hear an echo clearly, the minimum distance of reflecting the surface should be half this distance, that is 17.2 meter, that is a half of 34.4. Okay, to hear the echo clearly, you must be standing at a distance of 17.2 meter, and then only you can hear the echo, because the travel of your sound till your reflecting surface must be at least 0.1 second. Okay, so next is your reverberation. Echoes may be heard more than once due to repeated or multiple reflections of sound from several reflecting surfaces. This causes persistence of sound called reverberation. You have gone through this concept of persistence. Persistence means what? Again and again you feel that you are hearing that sound again and again. That is known as persistence. In eyes also, for the visual also, you have this persistence of vision. Same is for persistence of sound. In big halls or auditoriums, To reduce reverberations, the roofs and the walls are covered by sound absorbing materials like compressed fiber boards, rough plaster, or draperies. Means the cloths are done, or any of the wood furnishing is done over there, okay, to avoid the reverberation. So, what are the uses of this multiple reflection of sound? First, the megaphones, horns, musical instruments like trumpets, shehnais are designed to send sound by multiple reflection in particular direction without spreading in all directions. See here, all the whichever the sounds are coming in, they are all concentrated in one point, okay, and then they are thrown out through a particular in a particular direction. Doctors listen to sounds from human body through stethoscope. The sound of heartbeat reaches the doctor's ears by multiple reflections. Generally, the ceilings of cinema halls and auditoriums are covered so that sound after multiple reflection reaches all parts of the hall. Sometimes a curved soundboard is placed behind the stage so that the sound after multiple reflections spreads evenly across the hall. You can see these types of speakers arranged. If you observe the speaker surface, the speaker surface is never flat, okay. Some of the speakers are flat, but they have a slight curve at the ends of their at right and left, okay. Observe the speakers, how are they, okay. They have a curved surface to avoid this multiple reflections. Now, the range of hearing. Human beings can hear sound frequencies between 20 hertz uh, to it is 20,000 hertz, okay. I think there's a typing mistake. It is 20,000 hertz, okay. The sound whose frequency is less than 20 hertz is called infrasonic sound. The animals like dogs, elephants, rhinos, whales produce and hear infrasonic sound. And sound whose frequency is more than 20,000 hertz is called ultrasonic sound. Like animals like dolphins, bats, rats, porpoises produce here ultrasonic sound. Bats use the reflection of ultrasonic sound waves to detect an obstacle or its prey. That is, if bat is moving over here, the bat produces the ultrasonic sound, then it strikes its prey, okay. See, it strikes its prey, and again the reflections are sent to the bat. If the reflections are very much faster, then it gains the knowledge that the prey is nearer to him. If the reflections are coming very slow, then he understands that that the prey is very far, okay. So to detect its obstacle or its prey, the ultrasonic sound is used, okay. The other uses of ultrasonic sound are, it is used to clean objects like electronic components. That is, they are kept in a cleaning solution and ultrasonic waves are sent into the solution. So due to high frequency, the dirt particles get detached from the component. As the dirt particles start dancing over there in the liquid, and they get cleaned. Ultrasonic sound is used to detect cracks in the metal blocks. Ultrasonic waves are sent through the metal blocks, and if there are cracks, the waves are reflected back and the cracks can be detected. It is also used in the ultrasound scanners for getting images of internal organs of the human body. That is the sonography for the pregnant women. Then ultrasonic is also used to break small stones formed in the kidneys, that is the kidney stone, into fine grains so that they are removed through the urine. So rather to avoid the kidney stone operations, they use ultrasonic waves so that they can break those big stones, and they which are easily removed by the urine. Next, sonar, that is sonar stands for sound navigation and ranging. It is a device which uses ultrasonic waves to measure distance, direction and speed of the underwater objects. So sonar has a transmitter and a detector installed in a ships. The transmitter produces ultrasonic sound waves which travel through the water, and after striking the object in a seabed, is reflected back to the detector. So you have seen the Titanic picture, correct? So the big rock which was big glacier which was going to strike the Titanic, how it was detected? It was detected with the help of sonar. Okay, they had sent the sonar travels the sonar waves, that is the ultrasonic waves are traveled at the bottom. See in the picture, they are traveled at the bottom like this, and when it gets a strike to the bottom, it spreads, it gets reflected, and then see, sorry children, it gets reflected to the ship. Okay, and then they come to know that there is something obstacle in their way. Okay, so the distance of the object can be calculated by knowing the speed of the sound in the water and time taken between the transmission and reception of the ultrasound. So what formula they are going to use is that 2d is equal to v into t, or d is equal to v into t upon 2, that is the distance traveled is 2d by the ultrasound. Okay, so that's why they have used 2d. Okay, so here this is the use of sonar. Next, everything we have learned about the sound, but main part is we need to hear. So how do we hear? We hear with the human ear. So the structure of human ear, the outer ear called the pinna. Yes, see in the diagram, this is the pinna. It collects the sound waves. All the sound waves are collected into the pinna. The sound waves passes through the ear canal. Okay, this is the ear canal. Okay, these are the ear canal to a thin membrane called eardrum. Here it is the eardrum. The sound waves travels through the ear canal, and then it goes to the eardrum. It hits this eardrum. The vibrations, the ear, as the sound waves travel and hits the eardrum, it starts vibrating. The eardrum starts vibrating. These vibrations are amplified by three bones of the middle ear called hammer, anvil and stirrup. See, hammer, anvil and stirrup, these are the three bones connected here. See, these are the three bones connected in the eardrum. The middle ear then transmits the sound waves to the inner ear. In the inner ear, the sound waves are converted into electrical signals by the cochlea. This is the very most inner ear. This is the cochlea. This converts the sound waves into electrical signals, and then it is sent to the brain through the auditory nerves. See, here there is a auditory nerve. Okay, and the brain then interprets the signals as a sound, and then you give your response. Okay, so here we have completed our lesson, that is the sound. Okay, in this chapter you need to focus mainly upon the characteristics of the sound. What is the amplitude, what is the wavelength, what is the loudness, what is the pitch. Then most important is the applications of sound waves, that is the ultrasonic sound, the infrasonic sound. What are the applications of ultrasound. Okay, how the bats use this ultrasound in detecting the obstacles, how the sonar works, and what is remaining now is lastly we have covered about the structure of your ear, how your ear functions. Okay, in the ear structure, the main part is your three bones, that is the middle ear. Okay, in revision you can remember that your ear is divided into the main three parts: the external ear, the middle ear and the inner ear. Okay, external, it consists of the pinna. In the external ear, middle ear, it consists of the three bones. Okay, and in the inner ear you consist of a cochlea, which converts the sound waves into the electrical signals and sends it to the brain. okay, and then there it is analyzed and you know it what sound is coming. Okay, so here we have finished our chapter. Please read it thoroughly and practice the definitions and the units which are given over there, and also practice the diagram of the ear and the function of the ear very properly. Okay, thank you children.